Hi everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 3, which is a pure Mathematics 3 for May-June 2021, and the code is 9709/31. Let's move on to question number 1. Question number 1. Solve the inequality 2 times modulus of 3x minus 1 is less than modulus of x plus 1. Okay, so first of all, I will rewrite the question. Now, according to the modulus definition, this is same as square root of x squared. Okay, so I'm going to apply this definition in solving this question. So the modulus 3x minus 1, it will be square root of 3x minus 1. And same goes to the modulus of x plus 1. So you will be getting these two square roots. Now, to eliminate the square roots from both sides, we need to square both sides. So once we have squared both sides, right? So the squares basically will be moved into both of these two terms on the left hand side. So 2 squared, okay, and then the square root and square can be cancelled off. Then I will be getting 3x minus 1 squared. And same goes to the right side. The square and square root will be cancelled off. Then I will be getting x plus 1 squared. Now when we do the expansion, a plus b squared, it will be a squared plus 2ab plus b squared. So I will be getting 4 bracket. Square of 3x is 9x squared. Then minus 6x plus 1. We apply this quadratic expansion. Then for the right hand side, it will be x squared plus 2x plus 1. Okay, so for the left hand side, when you do expansion, you will be getting 36x squared minus 24x plus 4. Then all the terms on the right side will be moved to the left hand side. Then I will be getting negative x squared minus 2x minus 1 is less than 0. Okay, so from here, 36x squared minus 1x squared, it will be 35x squared. And then 24x, negative 24x, and negative 2x, it will be negative 26x. Okay, and then for the constant, it will be plus 4 minus 1, that end up with plus 3. So this is the quadratic inequality that we are going to solve. Now, this quadratic function can be factorized into 2 linear factors. The first one is 5x minus 3, and the second is 7x minus 1. And it is less than 0. So when I let this factor be 0, I will be getting 3 over 5. And the other one is 1 over 7. Now, I will sketch the graph. So when you look at the quadratic curve, okay, this quadratic curve will be having a minimum point. So I just simply sketch a quadratic curve with 2 different intersection points with the x-axis. And then the first one is going to be, the one on the left hand side is 1 over 7. We get it from here, okay, from 7x minus 1. And the other one is 3 over 5. So then, since the inequality is less than 0, therefore we just take the region below the x-axis, because this is our x-axis. Right, so I end up with the solution x between 1 over 7 and 3 over 5. So that's the solution of question number 1. Okay, so now question number 2. Find the real root. Root means the x, right? Because your equation in terms of x, of this equation, giving your answer correct to 3 decimal places. Your working should show clearly the equation has only one real root. Okay, so first of all, copy the equation. Okay, then now the denominator will be moved to the right side. So then I will be getting 2ex plus e minus x equals to 3 times 2 plus ex. Okay, and then now here, do expansion. I will be getting 6 plus 3ex. Now, here, I will move all the terms to the left side. So I will be getting 2ex plus e minus x minus 6 minus 3ex. That equals to 0. So for this case, 2ex first term and the last term, so when you combine together, it will be negative e positive x, right? Negative ex. Then plus e minus x minus 6 equals to 0. So now, due to the e power negative e negative x, the exponential negative x, so to eliminate this e negative x, I have to times the whole equation by e positive x. So once I times, the first term becomes, okay, so we have a formula here, EA times EB, because this is EX times EX. So as long as this is the same base, we add the degree. So it becomes e to the power of a plus b. So from here, I will get negative e to x, because x plus x is 2x. So for the second term, ex times e minus x, it will be e0. Okay, then minus 6ex equals to 1. So e0 is basically 1. So now the whole equation I am going to times by negative 1. Then you will be getting e2x. Then I rearrange the negative 6ex will be my second term. So after you multiply by minus 1, it becomes a positive. So the middle term, which is the e0, this is basically 1. Okay, but then when you times by negative, it becomes minus 1. And mistake here, right side is 0. Okay, equals to 0. So here I'll get equals to 0. Now, from here, I will let my u be ex. So then I will be getting u squared plus 6u minus 1 equals to 0. Okay, so when you look at the question here, you have to show clearly that the equation has only one real root. Alright, so then now for this quadratic equation, I'm going to let a be 1, which is a coefficient for u squared, and then b is the coefficient for u, is 6, c is going to be minus 1. Then now, my u is minus b plus minus square root of b squared minus 4ac. This is a quadratic formula over 2a. Then now, I will just replace all the abc, then you will be getting minus 6 plus minus square root of b squared minus 4ac over 2a. A is 1. So from here, you will be getting minus 6 plus minus square root of 40 over 2. And now we are simplify. Okay, so it will be negative 3 plus minus the square root of 40. 40 is 4 times 10. So square root of 4, right? Square root of 40 is square root of 4 times 10. Then now it will be split into 2 square roots. So now square root 4 is 2. So at last I'm getting 2 square root 10. Okay, this is going to be 6. Then divide by 2. And then I will be getting negative 3 plus minus square root 10. Okay, so now my ex is going to be, because this will be my u, then my u is basically ex. So now my ex is going to be negative 3 negative square root 10 according to the u calculation here, or ex is negative 3 plus square root 10. Okay, so for your information, for the exponential graph, this is our exponential graph. Right? So your exponential graph always above the x-axis, because it's from the graph is always above the x-axis. So it means that it will be always positive. Meaning to say that the first expression for the ex is basically undefined, because this is going to be a negative value. Okay, so from here, we have to show that there is only one root, one real root, right? And you need to leave your answer correct to 3 decimal places. So from here, okay, so your x is going to be ln of negative 3 plus square root 10. So only one real root. Right, then now we need to calculate this using calculator and leave the answer correct to 3 decimal places based on the question. Okay, so from here, at last your x is going to be negative 1.818. So this is the solution of this question. Okay, so now question number 3. 3a, given that cos x minus 30 degrees is 2 sine x plus 30 degrees, and then show that tangent x equals to this expression. So now I will copy the identity here, and then from here I have to use the addition formula, okay, which is cos a minus b is going to be cos a cos b plus sine a sine b for the first term, or for the left hand side. Then for the right hand side, since this is a sine here, then I will be using sine a plus b. This is going to be sine a cos b plus cos a sine b. Okay, that's the formula that I'm going to apply in this question. So here plus cos a sine b. Okay, so now when you rewrite, okay, or just replace, the a will be x, the b will be 30 degrees. So I will get cos x cos 30 degrees plus sine x sine 30 degrees is going to be 2 times the sine x plus 30 degrees. Just refer to the red color formula. It will be sine x cos 30 degrees plus cos x sine 30 degrees. Okay, so now for your information, sine or cos 30 degrees is going to be square root 3 over 2. So this is square root 3 over 2. Then I will get square root 3 over 2 cos x plus sine 30 degrees is half. So half sine x equals to 2 times cos 30 degrees square root 3 over 2 sine x plus sine 30 degrees is half, then cos x. Okay, so now the 2 on the right hand side can be simplified by all the terms on the right hand side. So at last I will be getting square root 3 over 2 cos x plus half sine x. All the terms on the right side will be moved to the left side. So minus square root 3 sine x minus cos x equals to 0. Okay. Now from here, okay, basically we need to get tangent, right? Probably I will just combine, or I will just group the sine and cos. I will just separate the sine and cos. So I should say like that, alright? So now means that I will keep my cos on the left hand side. So it means that this term will be moved, right? Then I will be getting negative cos x. Then for the sine x, it will be moved to the right side. Okay, I keep it on the right side. Then from here, I will be getting square root 3 sine x minus half sine x. Okay, then now I get the same, I factorize the same term, which is a cos x. Then I will get square root 3 over 2 minus 1. Then from the right hand side, I will factorize the sine x. Then I will get square root 3 minus half. Okay, then from here, I will get the same denominator for both. So cos x times, make it to over 2. Then I will get square root 3 minus 2. Then for the right hand side, it will be sine x. Then you make it to over 2 as well. Then I will get 2 square root 3 minus 1. Then now, to get the tangent, right, we know that tangent x is sine x over cos x. So I will divide the whole equation by cos x. So I will be getting square root 3 minus 2 over 2 equals to sine x over cos x. It will be the tangent x here on the right side. Then here is going to be 2 square root 3 minus 1 divided by 2. And now we look at both sides. Both denominators can be cancelled off. Okay, And then now, in order to get the tangent x, the coefficient for the tangent x will be moved down to the other side. So my tangent x is going to be square root 3 minus 2 over 2 square root 3 minus 1. Okay, so, but then when you check with the given form, 2 minus square root 3 on top, so it means that I need to factorize negative from both numerator and denominators. So here is going to be 1 minus 2 square root 3. So at last the minus will be cancelled off. Then I will be getting 2 minus square root 3 over 1 minus 2 square root 3. So this is the expression for tangent x. Right, so let's check. Okay, so it's exactly the same now. Okay, now B, hence solve the equation. So it means that now this equation, this equation is same as tangent x because it's already mentioned here, okay? Means that we need to solve the tangent x. Right, so I will just write tangent x equals to 2 minus square root 3 over 1 minus 2 square root 3. And now it's given the x is between 0 and 360 degrees. Okay, so now your x is going to be, just refer to the quadrant. Right, then this value, okay, is going to be negative. Right, when you calculate this value, this whole value is negative. So therefore, it will be in the second and fourth quadrant. So now I will get the basic angle from the calculator, which is the inverse tangent of the right hand side. So here I will write like inverse tangent of right hand side. So it's going to be 6.2 degrees. Okay, here is also 6.2 degrees. But our angle is counted from the first quadrant. This is our first angle. And the second angle is the major angle, the bigger angle. Therefore, from here, I will write this is basically 180 degrees minus 6.2 degrees. And the second angle is going to be 360 degrees minus 6.2 degrees. Then at last, you will be getting 173.8 degrees and 353.8 degrees. Okay, so that's the solution B. Okay, now for question number 4. A. Prove the identity, right? You need to prove 1 minus cos 2 theta over 1 plus cos 2 theta equivalent to tangent squared theta. So I will start with the left hand side. Okay, so since we are given the cos 2 theta, then I will be using this formula. Cos 2a is 2 cos squared a minus 1, or probably 1 minus 2 sine squared a. So when you look at the numerator, it is 1 minus cos. Alright, that means I have to use the second form, because when I move the cos 2a to the left hand side, to the right hand side, I'll be getting 1 minus cos. So I will get 1 minus cos 2a is basically this negative 2 sign will be moved to the other side. Okay, so I will be using the second form to simplify the numerator. Therefore, my numerator is 2 sine squared theta. But for my denominator, it is 1 plus cos 2 theta. Therefore, I will refer to first form. Move this minus 1 to the left side and combine with the cos 2a. That is our 1 plus cos 2 theta. Hence, my answer will be 2 cos squared a. Okay, which is 2 cos squared theta. Then from here, the 2 will be cancelled off. Sine squared over cos squared, it will be tangent squared. So here I'm getting tangent squared theta. Okay, so done for this part. Now B, hence find the exact value of this integration. Because of the hence means that you have to use the previous working. So now integration from pi over 6 to pi over 3, 1 minus cos 2 theta over 1 plus cos 2 theta. It will be integrate. Okay, refer back to the previous. 1 minus cos over 1 plus cos. It will be tangent squared theta. So now I have to integrate tangent squared theta from pi over 6 to pi over 3. But then to integrate tangent squared theta, we need to apply the identity. So 1 plus tangent squared A is secant squared A. Okay, therefore the 1 will be moved to right side, becomes minus 1. So then from here, I will be getting integration from pi over 6 to pi over 3 secant squared theta minus 1 d theta. So when integrate secant squared theta, it will be tangent theta. The minus 1, you integrate minus 1 d theta, it will be minus theta. Okay, so now replace the theta by upper limits first, which is pi over 3. And then we minus when the theta is lower limit, which is pi over 6. Alright, so now tangent pi over 3, since the question asking for exact value, therefore tangent pi over 3, it will be square root 3. Then just rewrite the pi over 3. Now tangent pi over 6 is square root 3 over 3. Okay, so now when we simplify the first and third term, this is 1 of the square root 3. Okay, 1 times of square root 3, and this is 1 over 3 times the square root 3, 1/3 of the square root 3. So 1 minus 1/3, it will be 2/3. Therefore, I will write it is 2/3 of square root 3. So for the second and last term, okay, when you simplify this 2 pi, right, don't forget the minus, bring in, then at last you'll be getting negative 1 over 6 pi. So that's the solution of this question. Okay. Now question number 5. Solve the equation where P and Q are real constants. So since your equation has I, right, therefore you have to apply the quadratic formula to solve this question. So let me rewrite the equation first. The coefficient for the z squared is 1. So A equals to 1. B is going to be negative 2pi. The C is a constant, which is our negative Q. So the Z is minus B plus minus square root of B squared minus 4AC over 2A. So from here, it will be negative of negative 2pi plus minus square root of negative 2pi squared, because that's our B, minus 4AC over 2A. A is 1. Then now when we simplify, the first term becomes a positive value, which is 2pi. Then plus minus square of minus 2, it becomes 4. Then square of pi, it will be p squared I squared. And then minus minus is a plus, that end up with plus 4q divided by 2. So then from here, right, I will say 2pi plus minus. Now if you still remember, I square is minus 1. Therefore, this I square will be replaced by minus 1 here. And at the same time, the 4 is in common. Right, so I can factorize the 4. Then you will be getting negative p squared plus q over 2. And then the square root of 4 minus p squared plus q. this is going to be square root 4 times the square root of minus p squared plus q. So the square root 4 becomes 2. Okay, so then from here I will write 2pi plus minus 2 square root negative p squared plus q divided by 2. Then from here I will be getting the roots. So now the 2 will be cancelled off. Okay, all these 2 will be cancelled off. Then now my real part, obviously this is real part because this is the term with the I. So now I will be splitting it into 2 parts, right? So it will be square root of q minus pi, right? Instead of minus p squared plus q, I will write, it should be q minus p squared. Okay, I just rearrange this. Then plus pi, because I consider when it is a plus, and the other one is minus. So these are my 2 roots. Okay, when you solve the quadratic equation. Now, in an Argand diagram with origin O, the roots of this equation are represented by distinct points A and B. Given that A and B, now this is part B. Given that A and B lie on the imaginary axis, find a relation between P and Q. Okay, let's say for example, this is an Argand diagram. Here is real axis. This is imaginary axis. Since both A and B lie on the imaginary axis, probably here A, this is B. We are not sure the exact points, but these are the points A and B on the imaginary axis, which means there's no real part. Okay, no real part. So which means this square root must be negative, so that it will be a imaginary part. Okay, and this imaginary plus with the other imaginary, then means you will be getting the imaginary value for both roots. Okay, so therefore q minus p squared must be less than 0 because A and B are on the imaginary axis. Okay, the idea is to get the I. Alright, therefore from here we need to get the relation between P and Q. You can just move this minus P squared to the other side. Hence, your Q is basically less than P squared. Okay, that's the solution for part B. Now, C, given instead the triangle OAB is equilateral. Express Q in terms of P. So now let's say for example, I draw the diagram. Okay, say this is the Argand diagram. This is real part or real axis. This is the imaginary axis. OAB is equilateral. Equilateral means all same length. Okay, let's say here is the O, this is A, here is B. Other than same length, there are also same angles. So here will be 60, then here 60, and this is also 60. Now, when you look at this, right, since here is 60, that means this is going to be 60 as well. Okay, and just now we have solved. We know that this should be our roots. So I know that my real part is going to be square root, either plus or minus square root q minus p squared, and the imaginary part is the p, which means on my diagram, when I label, I will label here as p. Okay, then this is square root q minus p squared, and this is going to be negative square root q minus p squared. Alright, so from here, I can just refer to this triangle. Okay, this triangle. Then I know that this is going to be P. So I have opposite and adjacent sides of this right angle triangle. Therefore, I can use tangent. So tangent 60 degrees is going to be p divided by square root of q minus p squared. So tangent 60 is basically square root 3. Okay, and now we need to get the q as a subject. So I will move up this square root. So then square root is like square root a times square root b. I will just combine this into square root ab. So therefore this is square root 3 times q minus p squared equals to p. But then since we need to get the q as a subject, so now I will take square both sides. So the square and square root cancel off, but then don't forget this, right? Yeah, you cancel off, then I will get 3 bracket q minus p squared on the left hand side, but then the right hand side you will get p squared. So then from here, bring in the 3 because we need to get the q. Or probably the 3 I can just move to the right side directly. So q minus p squared equals to p squared over 3. So now my q is going to be p squared over 3 plus p squared. Then you will be getting 1 over 3 p squared plus 1 p squared, and now with 4 over 3 p squared. So this is our relationship between q and p. Okay, now next question, number 6. The parametric equations of a curve are x equals to ln 2 plus 3t, y equals to t over 2 plus 3t. Show that the gradient of the curve is always positive. So the gradient is basically the dy dx, which means now I need to get my dx dt and dy dt. After that, apply the chain rule. So now my dx over dt is going to be, okay, when you differentiate ln function, is going to be over fx. Then the numerator is a differentiation of the denominator. Therefore, we are getting f prime x. So that means, right, what I need to do is I will just write over 2 plus 3t. So differentiate 2 plus 3t is 3. This is my dy dx. Sorry, this is my dx dt. So now for the y is t divided by 2 plus 3t. So here we have to apply the quotient rule. Let's u equals to t, then your du dt. Okay, so let's u equals to t, then u prime is 1. Then after that, v equals to 2 plus 3t, then the v prime equals to 3. Okay, our formula is d over dt, okay, d over dt uv. This is a quotient rule. Then it's going to be over v squared. So v u prime minus u v prime. So then from here I will get dy over dt equals to square of 3 plus t, 2 plus 3t, okay, which is our v squared. Then vu prime. So vu prime is 2 plus 3t times 1 because the u prime is 1. Then minus uv prime. The u is t, the v prime is 3. Then from here I will get the same, I will multiply, alright, I will multiply by numerator. Then you will get 2 plus 3t minus 3t. So at last it will be 2 over 2 plus 3t squared. This is going to be the dy dt. So now once you have found the dx dt and dy dt, to get the dy dx, which is a gradient of tangent or just a gradient, so it will be the chain rule. Dy dx is going to be dy over dt times dt over dx. So rewrite the dy dt first. So 2 over 2 plus 3t squared. Now for your information, dt dx is same as 1 over dx over dt. Okay, so which means now I need to get 1 over this. So when I take 1 over this, it means that I'm switching the numerator and denominator. So I will direct switch. So it will be 2 plus 3t over 3. Okay, so be careful with this. Then from here, I notice that 2 plus 3t will be simplified. Okay, then now I will be getting dy dx as 2 over 3 times 2 plus 3t. So this is our dy over dx, which is the gradient. Okay, part B. Find the equation of the tangent to the curve at the points where it intersects the y-axis. So when it intersects the y-axis, that means x equals to 0. Okay, so when x equals to 0, so now I will copy my x, which is ln of 2 plus 3t. So 0 is ln of 2 plus 3t. So to eliminate the ln, we take both sides, the exponential. So E0, it will be E ln 2 plus 3t. So E0 is 1. E ln just cancel off, then I will get 2 plus 3t. So that means here, 3t is minus 1 because I moved the 2 to left side, becomes minus 2. So at last, the t is minus 1 over 3. Okay, so now we need to calculate the y value because later you need to form the tangent equation. So now when t equals to 1 over 3, your y just replace the t value into the given y, which is t over 2 plus 3t. So t over 2 plus 3t. That means this is going to be, okay, your t is negative 1 over 3, so negative. So here negative 1 over 3 divided by 2 plus 3 times negative 1 over 3. So I will get negative 1 over 3 divided by 2 minus 1. Therefore, it's 1 in the denominator. At last, your y is negative 1 over 3. So that means from here, I'm getting a point with coordinates 0 and negative 1 over 3. And now we need to get the tangent equation, which means we need to find gradient of tangent, which is also the dy dx. So when t equals to negative 1 over 3, we have just found the dy dx just now. Okay, so just replace the t value. So 2 over 3 bracket 2 plus 3t. So this is going to be 2 over 3 brackets 2 plus 3 times negative 1 over 3. Basically, the denominator here, okay, this part is same as the previous, right, which is 1. So then I will get 2 over 3 for my gradient of tangent. So then, final answer, equation of the tangent. Y minus y1 equals to m bracket x minus x1. So this is x1, y1. So x1 is 0, y1 is negative 1 over 3. So I will get y minus negative 1 over 3. And this is our m. Okay, so 2 over 3 bracket x minus 0. Then from here, you will be getting y equals to 2 over 3x. Here is plus 1 over 3. So when you move to the right side, it will be negative 1 over 3. So this is the solution of this part. Okay, next question, number 7. The diagram shows the curve inverse tangent x over square root x and its maximum point m where x equals to a. Show that a satisfies the equation. Okay, so since x equals to a, alright, when x equals to a, it has a maximum point. So maximum point happens when dy dx equals to 0. So which means now I need to differentiate this. Okay, differentiate the y. So y equals to inverse tangent x over square root x. Again, this is quotient rule. Okay, so when we differentiate, okay, probably I will just write down the uv first. The u is inverse tangent x. U prime, we have a formula. When you differentiate inverse tangent x over a, it will be a over a squared plus x squared. Since this is x only, so that means x over 1, which means your a is 1. Okay, that means my u prime is going to be 1 over 1 squared plus x squared. So the 1 squared, you can just simplify to 1. And this is my differentiation. So then my v is square root x. This square root x is same as x to the power of half. That means my v prime is going to be half x to the power of negative half, because your power half minus 1 is negative half. Then from here, I can simplify this into 1 over 2 square root x. Okay, and then use the quotient rule in previous question. So it will be over v squared. And then v u prime. Okay, minus u v prime. Okay, now it's mentioned here where x equals to a, you get a maximum point, which means dy dx equals to 0. So now I will just direct replace where x is a, dy over dx is 0. Then at last I need to show this. Okay, so left hand side 0. The first one, okay, I'm getting square root a bracket 1 over 1 plus a squared minus inverse tangent a multiply with 1 over 2 square root a, then over, okay, for your information, square and square root cancel off, then I will just get a, because just get x. So from here I need to get a is tangent of this, right? So now what I need to do is, okay, I will move up this a first. So when I move up, it is 0. Then this square root a and the first term I combine together. So square root a over 1 plus a squared. And then it minus, this is inverse tangent a over 2 square root a. Okay, and then now when you look at the question here, if I move the tangent to the other side, I will get inverse tangent a. So means that inverse tangent a should be one term. Okay, it will be on one side. So now I will have to move this to the left side. So inverse tangent a over 2 square root a equals to square root a divided by 1 plus a squared. Then now I get the tangent, inverse tangent a as a subject. So then you have to move this 2 square root a to the right side. So then I will get 2 square root a, it will be a. Okay, so I'm getting 2a over 1 plus a squared. And then now what I need to do is just to move this inverse tangent to the other side. So now my a is going to be tangent 2a over 1 plus a squared. So this is how we show this, right? So shown. Okay, so done for this part. Let's move on to the next part. Now B, verify by calculation that A lies between 1.3 and 1.5. So I have to copy the previous equation and I move this tangent to the left hand side. Okay, so I will write A minus tangent to A over 1 plus A squared equals to 0. Then I will let these two terms be FA. Now we need to prove that it lies between 1.3 and 1.5. So just replace the A by 1.3 and 1.5. And when you do the calculation, make sure you change the radians, the mode of the calculator to radians. Okay, this is in radians mode. Alright, because there's no degree sign inside the bracket. So then when you calculate this value, it should be 0.148, which is less than 0. And now we need to calculate for f1.5. Then this is going to be 0.178, which is greater than 0. So since now f1.3 is negative and f1.5 is positive, so according to sign change rule, so there is a sign change. Okay, as long as there is a sign change, means one positive, one negative, then there is a root. So hence, A lies between 1.3 and 1.5. Okay, so this is the way to prove that a root lies between two numbers. Now C, use an iterative formula based on the equation in part A to determine A equal to 2 decimal places. Give the results of each iteration to 4 decimal places. So now, since your A between 1.3 and 1.5, I will take the middle value, which is 1.4. Okay, so and at the same time, we look at the formula in part A. So for according to the iterative formula means that for the left hand side, you have to add on the subscript of n plus 1 to the A, and for the A on the right hand side, you have to add on the subscript of n. Okay, therefore, I will be getting this formula. A n plus 1 equals to tangent 2an over 1 plus an squared. Okay, and then now you can fix any initial value of A. You can let it be 1.3, 1.5, or any values in between, up to you. So I'm choosing 1.4, the middle value. And I will get A1 equals to tangent 2 times 1.4 over 1 plus 1.4 squared. Then you will be getting 1.3865 because of the 4 decimal places. Then my A2 is going to be tangent 2 bracket 1.3865 over 1 plus 1.3865 squared. Then you will get 1.3951. Okay, when do we stop this iteration process? Since we need 2 decimal places, make sure these two are same numbers. Okay, so obviously they are not, therefore we have to continue. So my A3 is going to be tangent 2 bracket 1.3951 over 1 plus 1.3951 squared. Then this is going to be 1.3896. So again, they are not the same. So A4 this is going to be 3931. Okay, so let's do another one. A5. This is going to be 1.3909. Okay, so when you compare, Previous was 1.39. Now you get 1.39 if correct to 2 decimal places. Therefore, final answer based on the next digit. Since this is 0, we just ignore the 0, 9. Therefore, my A is approximate to 1.39. So that is my A solution. Okay, now for question number 8. With respect to the origin O, the points A and B have position vectors given by OA and OB. Now the line L has equation R equals to 2, 3, 1 plus lambda 1, negative 2, 1. Now A, find the acute angle between the directions of AB and line L. So now I need to find the vector AB first. So AB equals to OB minus OA. Alright, so I minus 3, 1 minus 2 minus OA is 1, 2, 1. So when you minus first component, okay, 3 minus 1 is 2. 1 minus 2 is going to be minus 1. Minus 2 minus 1 is minus 3. So then for the L, because our formula is basically R equals to A plus lambda B. So the B is a direction vector. Therefore, I will write B equals to 1, negative 2, 1. Okay, so to find the angle between the vector and the line, let's say this is the line, this is the vector AB. Okay, then you have to refer to the B, the vector B, direction vector from the line, and also vector AB. Then this will be my angle. Alright, so let theta be the angle between AB and L. Okay, so now I will write AB dot B equals to magnitude AB, magnitude B cos theta. This is the scalar product formula. So now when we dot product, so this is going to be 2 minus 1 minus 3 dot 1 negative 2 1 equals to the modulus is square root of 2 plus square of minus 1 plus square of minus 3. This will be the magnitude of AB. Then square root of the magnitude of B is going to be 1 square plus minus 2 square plus 1 square. Then cos theta. Then now for the scalar products formula, we need to multiply and add up all the multiplication. So here I will get 2 times 1 plus minus 1 times minus 2 plus minus 3 times 1. So for the first square root, this is 4 plus 1 plus 9. So you will get 14. Okay, then the other one, 1 plus 4 plus 1. So it is square root 6. So for the left hand side, this first term is 2. Second term is 2. Okay, 2 plus 2 is 4. Then minus 3 is, 4 minus 3, you will get 1. Then from here, my cos theta is 1 over, these two we can combine, otherwise we can just leave it. Alright, so I will just combine. Then now, my theta is going to be inverse cos. Okay, inverse cos of this expression, 64. 16 times 4, 84. Okay, then here it's going to be 83.7. So you can just get this value from the calculator, and this is our acute angle. Alright. Okay, so next part. Find the position vector of the P on L such that AP equals to BP. So now, let OP, because the P is on L, that means OP, vector OP is same as the R, which is equals to Okay, so I will combine the components 2 plus 1 lambda. Okay, for my first component. Second component is 3 minus 2 lambda. And then the third component is 1 plus 1 lambda. So here I will just write, this is going to be 2 plus lambda, 3 minus 2 lambda, and at last it will be 1 plus lambda. Okay, and now we need to get what is your AP and BP vector. So basically, vector AP is same as OP minus OA. So then now I will write 2 plus lambda, 3 minus 2 lambda, 1 plus lambda, minus my vector OA from the previous part. So OA is 1 to 1. So it means that the term without the lambda is just simplify. Okay, just minus. So 2 minus 1, I will get 1. Therefore, it will be 1 plus lambda. Then 3 minus 2 is 1. So 1 minus 2 lambda for the second component. 1 minus 1 is 0. Just left lambda. And same for vector BP. So even though the question does not mention it is these two are vectors, but we know that as long as vector and this AP is basically the length, okay? Length of AP and length of BP. So length of AP is you can get it from the vector as well. So you can refer it to vector as well, right? So length of AP is same as length of BP. Or in other words, vector AP is same as vector BP. Okay, so I should say it like that. So therefore, I'm referring to the vectors and instead of the length. So now your OB, again from the question. OB is 3, 1 minus 2. So here I will get 3, 1 minus 2. So then when you simplify, again 2 minus 3 is minus 1. So then the 3 minus 1, you get 2. Lastly, 1 minus minus 2 is 3. Okay, and then now you need to find the position vector of points P. So instead of using the the vector first, now I will just equate them first, equate the vectors first, right, instead of the length. So I will consider the vector first. Then from here, okay, so if I have found the vector here, now just for information, may refer to the question here, such that AP is BP. Okay, so now after I found the vector, then only I will consider the length of these two vectors. Because if I direct consider these two vectors, if I equate these two, my lambda, you see all the direction vectors which is here will be the same. So when you simplify, when you equate them, means that the lambda will be cancelled off. Okay, so now since you have found these two vectors, then now we need to consider the length of these two vectors, then equate them. Alright, so I should write this is the modulus both magnitude will be the same. Okay, so for the first magnitude, I will get square root of 1 plus lambda plus square of 1 minus 2 lambda plus square of lambda. That will be the magnitude of AP, and it's so magnitude of vector AP is also same as just AP. So then for the right hand side, it will be square root of minus 1 plus lambda squared plus 2 minus 2 lambda squared plus 3 plus lambda squared. Then now, to simplify these two square roots, basically we are squaring both sides. Okay, basically we are squaring both sides. So the square and square root cancel off. Okay, and then now we need to expand. So first term, you will get 1 plus 2 lambda plus lambda squared. The second term, when you do expansion, it will be plus 1 minus 4 lambda plus 4 lambda squared, and then copy the lambda squared. Now for the right hand side, when you do expansion for square of minus 1 plus lambda, it will be 1 minus 2 lambda plus lambda squared. Then the second term is going to be 4. Okay, square of 2 is 4. Then minus 8 lambda plus 4 lambda squared. And lastly, square of 3 plus lambda is going to be 9 minus 9 plus 6 lambda plus lambda squared. Okay, so now when you check the left and right side, so here I have lambda squared, 4 lambda squared, and lambda squared. Same goes to the left side, exactly the same, which means all this will be cancelled off. Okay, then now I will move all the terms to the left hand side. Or before I move that, probably I will simplify first, then it will be easier. So for the left hand side, here I will be getting 1 plus 1, which is 2. 2 lambda minus 4 lambda is minus 2 lambda. Then for right hand side, I'll get 1 plus 4 plus 9, which means it's 14. And then I'm also getting minus 2 lambda minus 8 lambda, so minus 10 lambda. Then minus 10 lambda plus 6 lambda, it will be minus 4 lambda. Okay, so to get the vector OP, okay, to get the vector OP, we need to find the lambda value. Therefore, I will move my minus 4 lambda to the left hand side. So minus 2 lambda plus 4 lambda. Then the 2 on the left side will be moved to right side. So it will be 14 minus 2. Then from here, my 2 lambda equals to 12. That means the lambda is 6. Once I found the lambda value, then I will substitute into my OP. So which means now my OP will be 2 plus lambda, 3 minus 2 lambda. And the last one is 1 plus lambda. So now you replace the lambda by 6. Then here you will be getting 8. So 3 minus 12 is minus 9. 1 plus 6, 7. So that's my OP. Okay, next question, number 9. The equation of the curve is y equals to x to the power of negative 2 over 3 ln x for x is greater than 0. The curve has one stationary point. So whenever you see stationary points, means that dy dx equals to 0. Now find the exact coordinates of the stationary points. Only one stationary point here. Means that now y equals to x to the power of negative 2 over 3 ln x. So I will use the product rule. The first term is my u. Therefore, my u prime is negative 2 over 3x. Then the degree u minus 1 from the existing value. So it will be negative 5 over 3. Then my v is ln x. When I differentiate ln x, my v prime is over x first. So when I differentiate x is 1. Okay, so now product rule. Differentiate uv, it will be uv prime plus vu prime. So then from here, I will be getting my dy dx is x to the power of negative 2 over 3, which is my u. V prime is 1 over x plus ln x the v times u prime. So negative 2 over 3 x to the power of negative 5 over 3. Then now from here, my dy dx equals to 0 because of stationary point. So 0 equals to, when I simplify these two terms, okay, this is degree 1 in the denominator, but when I move up, we have a formula here, a power m times a power n, it will be a to the power of m plus n. So this negative 1, okay, when you move up the x power 1 from the denominator to numerator, you move up, so it will be power of negative 1. So when you add up negative 2 over 3 and negative 1, it will be negative 5 over 3. Therefore, I will get x power of negative 5 over 3. Then plus, okay, don't write plus, combine these two terms first, it will be minus. So it will be negative 2 over 3. Okay, so it should be negative 2 over 3 x power negative 5 over 3, then ln x. Then from here, I notice that the x to the power of negative 5 over 3 is in common. Then you factorize the common term, you get 1 minus 2 over 3 ln x. Okay, so now when multiplication of two terms equals to 0 means that one of them must be 0. But we know that x to the power of negative 5 over 3 cannot be 0 because it is 1 over x to the power of 5 over 3. The x is in the denominator, so it will not be 0. Therefore, 1 minus 2 over 3x must be 0. So now I move the negative 2 over 3 ln x to the right side, then it will be 2 over 3 ln x equals to 1. Okay, so now ln x is going to be 3 over 2, and hence my x is going to be exponential 3 over 2 because the question says exact coordinates. Right, so no decimal. Therefore, this is going to be my x coordinate. So once you have found the x coordinate, to get the y, just substitute back into your curve equation. So x equals to e to the power of 3 over 2. The y is x power negative 2 over 3 ln x. So this is going to be e 3 over 2, but with degree of negative 2 over 3. Now for the ln x, right, you can just replace the ln x by 3 over 2. So then from here, 3 over 2 and 2 over 3 will be cancelled off, but then still have the negative. That means I'm getting 3 over 2e degree 1. Okay, because the e power negative 1. So therefore, the stationary point with coordinates e to the power 3 over 2 and 3 divided by 2e. Okay, so done for this stationary point. Now B, show that the integration equals to 18 ln 2 minus 9. So now integrate 1 to 8 y dx, it is integrate 1 to 8 x to the power of negative 3 over 2 ln x. Let me check. The y is x to the power of negative 2 over 3. Okay, so when we need to integrate this, alright, the first term is x degree negative 2 over 3, and the second term is ln x. So it means that for this integration, we need to use integration by parts. So now my u is going to be ln x. So my du dx, it will be over x, differential x is 1. Now my v is going to be x to the power of negative 2 over 3. So the v prime. So the v is to integrate this. So when you integrate negative 2 over x to the power of negative 3 over, when you integrate x to the power of negative 2 over 3, it will be you plus 1 to the existing degree. So negative 2 over 3 plus 1, you'll be getting 1 over 3. Then over 1 over 3. So but then when you simplify this, is basically 3x to the power of 1 over 3. And now, according to the integration by parts, so integrate u dv dx, or uv prime, I would say uv prime, or here probably I will just write dv dx because I use du dx. Okay, so u dv dx equals to uv minus integrate v du over dx. So if with limits ab, so you just add on the limits for all the terms. Alright, so now here I will just apply the formula uv. So I will write 3x to the power 1 over 3 ln x with limits minus v du. Then now replace the x by 8 first. So I will get 3 8 to the power 1 over 3 ln 8 minus 3 times 1 to the power 1 over 3 ln 1. Then minus, okay, when we simplify these two terms, this is degree 1. So when you divide means that you minus a degree. So 1 over 3 minus 1, which is negative 2 over 3. So I will get integrate 1 to 8, 3x negative 2 over 3. Alright, and at the same time, the ln 1 is 0. So it means that this whole term is 0. Okay, and when you refer to the answer here, we need ln 2. And now I get ln 8. So we know that 8 is 2 cubed. Okay, ln 8 is ln 2 cubed. We have a formula. Ln a power b is b ln a. So the 3 can be brought down. Then you get 3 ln 2. So here, 8 to the power 1 over 3, this is going to be 2. Alright, so 3, 2. Then this is going to be 3 ln 2. Then minus integrate 3x power of negative 2 over 3. So which is this result. Right, for the x itself, it will be that result. Don't forget there's a minus 3 outside. So I times by 3x power 1 over 3. 1 to 8. Okay, then here 3 times 3, 9, 9 times 2, 18, so I get 18 ln 2. Then you will be getting this 3 brought down, take it out, it will be minus 9. Then replace the 8, replace the x by 8 first. So 8 power 1 over 3 minus 1 to the power 1 over 3. So then you will be getting 18 ln 2 minus 9. 8 to the power 1 over 3 is 2, okay, from the previous. So 2 minus 1. Therefore, this is going to be 18 ln 2 minus 9. So, shown. Okay, so this is the solution of this integration. Now, question number 10. The variables x and t satisfy the differential equation, and x equals to 1 when t equals to 0. Use partial fractions, solve the differential equation, obtaining the expression for t in terms of x. So now, first of all, I have to split the variables, separate the variables first. Since your dx is the numerator, that means all the x should be on the left hand side. So I will move down the x squared and 1 plus 2x. It will be 1 over x squared bracket 1 plus 2x. Then dx, and this dt will be moved to the other side. And now add on the integration sign. So this is what you need to solve. But before we solve this, we have to find the partial fractions for the left hand side first, which is this rational function. So 1 over x squared bracket 1 plus 2x. Now the first term is the repeated factor. Therefore, I have to write over x. We start with degree 1 for repeated factor, then until the given degree. And since all these are considered as linear factor, the first one is repeated but it is linear. Okay, so I will write a, b, c, all the constants for the numerator. And now you compare with the left hand side. So here I will get a over x. So when you compare to the left hand side, instead of x, I need x squared. Okay, I need x squared instead of x. So it means that I need to times with x together with the 1 plus 2x. So for the second term, you have x squared. Already have x squared, just times with 1 plus 2x. This is times. Same goes to c. So you times with x squared. Alright, so now from here, just ignore all the denominators and write down the numerators. Then now, to find the ABC, just let the factors be 0. So first of all, my first factor is x. So I will let x be 0. Left hand side always 1. As long as you see the x, that means this term is 0. Okay, then I will get the b. So 1 plus 2 times 0 will be my coefficient of b, which means 1 is 1b. Therefore, my b is 1. Now, next is I will let 1 plus 2x be 0 to get the x value. So it means that my x is going to be negative half. So then left hand side is still 1, means that now as long as you see 1 plus 2x, this whole term is 0. Okay, which means I can find the c directly. Therefore, 1 is 1 over 4c. Hence, your c is 4. Now, the next step is to let x be any other numbers. Let's say I let my x be 1 because we don't have other factors. So let x be 1, left hand side 1, right hand side a times 1, then 1 plus 2 plus b bracket 1 plus 2 plus c bracket 1 squared. So from here, 1 equals to, this is basically 3a plus 3b plus c. So now replace the b and c that we have just found. So for the left hand side, for the right hand side, you will get 7. Okay, this 7 you move to the left hand side becomes minus 7. So 1 minus 7 is minus 6. Hence, my a is going to be negative 2. So found the a, all the unknowns, a, b, c. What to do the next is just to rewrite. Alright, so 1 over x squared bracket 1 plus 2x is going to be negative 2 over x. Then the b is 1. The c is 4. Okay, so now we need to solve this integration. just substitute back to the left side. So integrate 1 over x squared bracket 1 plus 2x dx is integrate dt. So now I will write integrate negative 2 over x plus 1 over x squared. Okay, this one was x squared, I will move up. Right. So, or probably I just copy the general form first. Okay, it will be better. So here is going to be, okay, now when I integrate this, we have a formula. Integrate f prime x over fx dx equals to ln fx plus c. So now I will write integrate over x, okay, dx. So when I differentiate x is 1, but to get the minus 2, I times minus 2 outside. Then for the second term, I move up. Okay, same goes to the right, the last term. I will write over 1 plus 2x first. I use the ln because the degree of the denominator is 1. So differentiate 1 plus 2x is 2. But to get 4, I times 2 outside. The right hand side is basically integrate 1 dt. Therefore, it's t, then plus c. Okay, or I don't want to write plus c first because I have not done the integration yet. So I will do the integration at the same time. So for the left hand side, I will get negative 2 ln x. Then for the second integration is basically you plus 1 to the degree. So minus 2 plus 1 is minus 1 over minus 1. Then for the third integration is 2 ln 1 plus 2x. The right side is t plus c. Okay, so here, when you look at the question, it's mentioned that x is 1, t is 0. So now x is 1, t is 0. That means we will be getting negative 2 ln 1 because x is 1. This plus and minus is minus. So I will get minus 1 at the denominator here, and this x power negative 1 will move down. So it means that it will be negative 1 over x. So negative 1. Right? Then plus 2 ln, where x is 1. So I'll get 3. Then t is 0 plus c. So from here, ln 1 is 0. Therefore, I will get minus 1 plus 2 ln 3 equals to c. Okay, so now rewrite minus 2 ln x. As I've mentioned just now, this is basically negative 1 over x. So negative 1 over x plus 2 ln 1 plus 2x. That equals to t plus c. And then the question says, get the expression for t in terms of x. Means that the t as a subject. Alright, so keep the t one side and the rest move to the other side. Means now I have to move these two terms to the other side. And at the same time, I will write my t on the left side, okay? So my t is going to be, so the rest just copy. And move the minus 1 plus 2 ln 3 to the other side. So we need to change the signs. So here will be plus 1 minus 2 ln 3. And try to simplify. Okay, we have a formula here. Ln A plus ln B is ln AB. And ln A minus ln B is going to be ln A over B. Okay, so you may look at here. 2, 2, 2. Right, factorize the 2 first. Then keep the minus outside, no problem. So I will write equals to 2, then minus ln x plus ln 1 plus 2x then minus ln 3. After that, the remaining terms will be minus 1 over x plus 1. Okay, then from here, now these two minus can be combined first. Okay, then now here I will get negative combined with the plus, therefore it's times ln 3x. So now use the minus of 2 ln. So it means that it will be 2 ln 1 plus 2x over 3x. Then minus 1 over x plus 1. So this is our t. Okay, express t in terms of x. So this is the full solution. Right, so we have come to the end of the video. Thank you for watching. Please subscribe to my channel and recommend it to your friends. And also stay tuned for more upcoming videos. Thank you. Bye.